Alright. Hey everybody, my name is Dylan Pogue and I'm going to be going over test-driven development. Um, just a quick presentation, going to explain a little bit about it in the PowerPoint, and then I'm going to move on and actually show an example of how you can use test-driven development to write better code. What is test-driven development? Often referred to as TDD, test-driven development is a software development approach where tests are written before the code is implemented. The idea behind this system is to create a test that will fulfill your requirements, and then by writing your code to accomplish that test, you are fulfilling your requirements. Then, after you have successfully passed your first test, you can move on to creating more tests that will fulfill more of your requirements and therefore progressing and improving your project. While researching online, I found that the TDD cycle can often be shown using red, green, and a refactor. I'll have another photo of this on the next slide. But the idea is that your red is where you're writing your failing test, which is whatever requirement that you're trying to accomplish that isn't working. Then the green is that you're writing the code that should, in theory, pass that test. And then the refactor is refactoring, which is tidying up your code or correcting anything that didn't work. And then you go back to writing another failing test, assuming you passed. If not, you go back, you check your test, and then you rewrite your code and then refactor again if it's still not working. But basically, you're following an endless cycle that should constantly keep improving code. And here is a photo of the red green refactor cycle written that way, as I was referring to. And so as you can see, write a test that fails, make only enough code for it to pass, and then you code quality during the refactor. And then you can either continue on with the next test, or you could go back and relook at it if something didn't work. Next, I have a slide on why you should use TDD. And there's several reasons, but the main ones are early bug detection, because if you're constantly going back and checking that your code is meeting your test, you'll catch any bugs early on, which is always great because otherwise they end up catching you later on or possibly even in production, which is a real problem. You should have improved code quality because as you're going through this whole testing process and everything, keep looking at your code over and over. You will keep changing it, keep refactoring it, and refining it, and making it such that your code should be very robust, and work well for your test cases. You should be able to achieve faster development cycles because if you know that you're going to be accomplishing just the minimum of that test each time, it makes it easier to see where your errors are and what you need to change. And so you should be able to move faster as a team to accomplish that goal. And then better design through refactoring, that kind of just goes hand in hand with the improved code quality. It should keep improving and making your code better, and it should work better and faster and just overall greater for the test cases. And then the increased confidence in code changes is that while you keep going through this cycle, you'll be able to increase your confidence in code changes, not just for the betterment of yourself, but then also for the betterment of the project because you'll be more familiar with the code because you keep going through it. Common mistakes that programmers run into are the initial learning curve and then also writing meaningful tests, because that's pretty much a huge deal when it comes to writing these test cases. Is if your requirements are creating a poor test, then your test won't be able to make your code very good. And if your code's not very good, the whole thing just isn't worth doing. So you have to make sure that you're understanding not only just how to create these tests, but what makes them useful when writing your code. Now, how to learn TDD. So, two major points when you're trying to learn or teach your team how to use TDD. You should start small and gradually expand the TDD practices, and then also invest time in writing good tests. Just like I was saying on the mistakes, you aren't focusing on making sure that your test accomplishes your requirements and is a good, like well written test, then your code is not going to end up being what you need it to be. and then you're going to spend all your time having to refactor and refine and change, all because the real problem was in your test, that your test didn't actually accomplish what you needed it to accomplish. So you have to make sure that you start small, and as you get more comfortable, you can start adding more difficult tests and making better code and improving it and going throughout the whole process. Now let's look at an example. I'm going to switch over to some code that I was writing a little bit earlier. It's just a real simple example of a test and a test case. And we're going to go through that and just kind of walk through the process of how it worked for me to set it up in Visual Studio 2022. I know a lot of our other classmates are using the same thing. I'm going to do just a real quick walkthrough and then try and explain a little bit of some of the troubles that I ran into. All right, so now we've moved over to Microsoft Visual Studio 2022, which is the version that I was using that I think most of the class also uses. So when you're going to go ahead and try and set this up to set up your test case, so the first thing is you want to set up your main program, which you need to set it up as a class library. Don't set it up as a console project, because if you do, it won't work with your test case. So set it up as a class library. Then you're going to create your namespace calculator.core, and then put inside of it, you'll have a math operations is what I'm using, because I wanted to do addition and subtraction just to keep it real simple. So as you can see, it'll return a plus b. On the other one, it will return a minus b. Then you could add other methods if you wanted to, but for our case, this is all we need. So after you've created what your main program is going to be, you're going to go up to File, and you're going to add a new project. And that new project needs to be one of these NUnit test projects. You're going to go ahead and add that in. I'm not going to do it here because I've already got one created, but you're adding that in because that's how you're going to actually test your program. So then you'll create your test program, which on mine, as you can see, so it's public class math operations tests. And so basically what it's doing is it's looking at what was done on the other one, and it's saying that when you add 2 and 3, you should get 5, and then it'll check and make sure that 5 is equal to 5. And then on the other one for the subtract, if you take away 3 from 5, it's checking to make sure that you get 2. You can see that assert.r equal makes it such that 2 is equal to the result, which means that it's correct. So that's how you're going to write your test case. Once you've written your test case, you're going to go ahead and go over to the side, and where you see calculator.test or whatever the name for the one that you're actually using as your test case, you're going to go over there, you're going to right click that one, you're going to go down to add, then you're going to click on project reference. From project reference, you should see your other project pop up right there on top of the list, but the difference is that the box isn't going to be checked. So you're going to need to check that box, and then you're going to hit OK, so that it'll save that. And after you've done that, you can actually go up to test, and then you can run all tests right there, or you can go into Test Explorer. And when you go into Test Explorer, you'll see a more broken down version. As you can see, mine's already got all these checks because I already ran it earlier to make sure it was working. But then you're just going to go ahead and click this like play arrow basically. It'll run your test. You can see build 2 succeeded, 0 failed, so that all went well. And then all these check marks mean that as it did its checks, the code passed. And so that means that 2 plus 3 is equaling 5, and 5 minus 3 is equaling 2. So everything's good. If something were to go wrong, you could see it right here in the failed test. Or sometimes one of the problems I ran into when my 2 pages weren't connected at first, I was getting no checks and no X's, and it was just because it was saying we don't have anything to test because you haven't connected the 2. And that was pretty easy to figure out how to connect them, because that was just adding the reference and going and checking that box. Well, that pretty much sums up test-driven development. If anyone has any questions, please feel free to contact me. You can reach me at my ETSU email, which is pogdj@etsu.edu, or you can send me a message over Discord. My Discord username is just Dylan Pogue, DYLANPOGUE, no caps, spaces, or anything. Feel free to shoot me a message over there if you have any questions about it. I hope that the video was informative. I hope that any roadblocks that you guys might come into, that either I can help you get past it or anything like that, but just let me know. and I hope you guys enjoyed the video. Thank you very much.